Okay, think we have sound. Yes, let's see, do we have shot? We have shot. Welcome everyone. So we are back to Milo modification CAD series. So first, good night everyone. How's everyone doing? Yeah, let's get back to it. So again, for those who are new, we are starting, we're gonna start kind of soon Milo build, and since I have some experience with CNC machines and building CNC machines, I decided to put my twist on this project, and I'm gonna make some modifications because there are some design stuff that I'm not agreeing with, so I'm gonna make my own. Some stuff I don't agree, but it's too not complicated, but it's gonna make it quite hard to change it to my liking, so I'm not gonna mess with it. The idea is for everyone who's assembling this machine to be able to do the same modifications. Yes, I'm gonna machine some parts of aluminum myself, but yeah, most of them you can just 3D print them. The idea is also to maybe make an available kit for those who really want the machine to perform as it should. Anyway, so it's just my twist on it. I'm not saying that I know everything there is to know about this, because I don't. I'm always learning every day, as everyone. But there are some stuff that I really don't agree, and I'm gonna make the changes. So first of all, we're gonna do it everything in CAD, so I can order the materials needed. Because I'm gonna need to outsource plenty of stuff like ball screws and whatsoever. So I'm gonna make everything in CAD first. So first, I know everything will work out, and then it takes time to get stuff here in Portugal, so we can continue other projects while waiting for the stuff for this one. So yeah, let's go into it. Let's go back to CAD and open the mock-up model, or the functional assembly as I call it, which is just a plain and simple design of all the parts, just not pretty, just functional design with accurate dimensions and whatsoever. Just doesn't look as pretty as the official design, but in dimensions everything will match. So I can do assembly with joint motion, so I can see every piece moving, see if we have interference on anywhere whatsoever, what we need to mod, what we need. It's always a good idea to make a simulation model first, and that's pretty much what I'm gonna do. And yeah, let's go to it. So let's open Fusion. Actually, I have Fusion open already. So this is a part we were designing yesterday. And yeah, this is where we stopped yesterday. I'm gonna push this a little bit to the front again. I was doing some... Hey Nuno! Yeah, I'm on time. I said today I should start a little earlier, and I did. Just 15 minutes earlier. But the stream was scheduled for this time, so I just started. Okay, so Yeah, I'm gonna put 25 in here. Save. Let me open the original model. Yeah, usually I start at 9, but yesterday I said I would try to start a little earlier today, and I actually scheduled it to 8:45. So here we are. Okay, so here we have the model. Here we have the Y mount, motor mount, motor slash bearing mount for the. Okay, Forza. Okay, so Nuno just asked if we just want to make a quick question in Portuguese to be faster. Let's see what he asks. Okay, so let's update it. So I intend to use different motors, as I said, but I'm gonna use the same size of couplers just to make everything easier. I decided to go with it. So let's check which couplers the guys are using here. Shit, okay. I believe they are 29 in diameter, no, 25 in diameter, and I think it's 29 in length. Uma tampa com a parte de cima curva. Epá, depende do formato, mas tipo uma tampa redonda ou quadrada? Okay, so Nuno is asking how to make a curved surface like on Olá, Margarida. It's my goddaughter, sadly. Okay, so he sent on Discord. Let me open Discord. I'm gonna open it in my computer. It's not this one, it's here. Okay, that's not an easy one to do. So that one, it's kinda an organic shape. I honestly, I don't master that kind of. I would need to think a while about it. Probably I don't even know. It's kind of organic shape, and I really don't know much about this, but I would take a look into the, let me open Fusion, into this thingy, the form thingy. Because with the form, you can start with a box or with a sphere or whatever. Actually, this is quite different since the last time I came here, but should be the same. With this thingy, you can grab and stretch. Well, usually you can grab and stretch, modify. Jesus, I need to take a look. This is much completer now. Quite different since the last time, so you can stretch it, see? With this kind of thing. You can grab corners, can move them away, whatsoever. Since we are at it, let's see. You can delete stuff. Let me see. Well, on shape, I have no idea. I never used on shape, so let me check something interesting. Now that we come into this, why did the other, okay, finish form. Can I do, if I do, let's say an ellipse. This is more like a circle, but and if I do like a cylinder, oh, a cylinder, oh, yeah, okay, fine. Let's do a fillet in here. And now if I go to form, and if I go to modify, okay, no, okay, I need to create a form in here. Yeah. Well, yes, photogrammetry, it's really cool. I tried it and it works amazingly well. Actually, no, I don't have it here. And I, Joseph, but to design it, I'm not, I would really like to know to mess with forms and shape and whatsoever with curved surface, but I'm just more of I don't even know what's the word, like squares and lines and straight lines, some arcs and stuff, but that curvy shit, I'm not the guy to talk with. I really would like to know, and I would like to learn, but I haven't had the time for it. Yeah, brutalist. Yeah, I know. Then I work with fillets and whatsoever to make rounding stuff more beautiful, but those organic shapes, it's not for me. I don't, sadly, I don't know how to do it. I would love to learn, but I would need like an actual class or some kind of a workshop to learn about that. Okay, that's private stuff. So no, I deal fine with these kind of designs. That's all good. Some of this stuff, I work fine with that, but when we go into the organic stuff, nope, that's not for me. SolidWorks, I know it's a little, you can do some cool stuff easily, like variable fillets, like start a fillet at with one radius and then grow it and then scale it down again. Yeah, Blender it's more for that stuff as well, but I see people designing cars on Fusion, so it's like, maybe it's not that complex, but as Blender I know you can actually shape and pull and whatsoever, but so yeah. Once I began a tutorial of the designing a complete 3D model of a car from photography, which was very fun. Pretty much the guy took like 3 pictures of the car, like from the top, from the front, from the side, and then starting to design the thing. But I never finished the tutorial, not even nearly. Usually when I don't have time to do the full course, I just want to get to the part that I really need, and then I skip everything. And sadly, I didn't finish that one. But yeah, it's something I really would like to. I really would like to know how to do, but it's not doing one time that we're gonna learn, because we're gonna forget most of the stuff we learn along the way, unless we keep doing. And yeah, I'm not a kid anymore. Kids are like sponges of for knowledge, and I find it's quite hard for me right now to retain the knowledge than it used to be like 10 years ago. Okay, so let's do some simple couplers for our design. So let's do a 25mm cylinder by 29, and one side we're gonna, actually this would be important to have let me see if I can find it, if I can find them on the kit real quick. Should be on the hardware box, and the hardware box should be here. Okay. Okay, so as I was saying, let me put the front yesterday. So the Milo kit actually comes with these type of collars for the LED screws, which are better than the ones that actually bite on the threads. Here we are. No, actually I don't know that game. Okay, these actually are good quality ones. They have proper hardened screws. They are proper tight, which is good. Okay, the only thing I really want to know is how deep the holes are. So we can go 12 millimeters. No, I don't know that one. Don't piss me off, or don't get pissed. Let's call it that way. Okay, where is the Brave? No, not Brave Fusion. So we have an 8 millimeter on one side. So that's for the ball screw. Oh, okay, I know Ludo, but I never played. I know from hearsay. I heard of it, and I never played. And this side's gonna be 6 millimeters. That's the motor side. But the motors I want to use, they have 8 millimeters, so I'm gonna need other couplers. Shit. So I assume this guy, where is my digital caliper? Is it here or is it there? It's probably there. No, it's not here. It's not here. It should be here. Oh, it's here. That's fine. That's cool. My trusty Shy. My trusty Shy. It's not very trusty, and I believe it's because of the battery. Sometimes they... Yeah, the battery is dead. Sometimes these batteries just fall over when we don't want, and when we need to take them apart, come on. When we need to take them out, they don't come out. Let's see if I have a battery here. Not sure if I do. What do we have here? What's this? So these are not the ones I need. Well, fuck. What's this? Nope. Shit. Well. Yeah, I only have downstairs, but I'm not feeling like going there. Let's see the model. Yeah. That looks cool. Do I have a spare in here? I don't think so. Yep, I don't. Okay, never mind. Let's do the lazy way. Like this. Now we lock it. Now we use the other one to measure. Yeah, it's the same thing. So the main thing is the on this caliper the depth thingy. It's too wide and doesn't fit the hole I needed to measure. So yeah, this battery is dead. Okay, I need to get another battery later on. Fine. Okay, let's call this guy, let's do a little chamfer just to make it a little less ugly. Like that. And let's call it functional. Let's call it coupler 2530 68. So 2530 would be the size, and there's my phone. Okay, so let's put the thing in here. Let me disable the analysis. And let's order in. So let's put it on the Y, because it's what it belongs. Let's rotate it. Oh yeah. So some dovetails maybe. Okay, I should have placed a joint and not a line. So I'm gonna press that and join, J for join, and there we go. And now the motor. So here I'm gonna use yeah, we can, let me see how are the motors in here. Yeah, they don't look too bad. They don't look too bad. So maybe we can just import a motor, because I'm not feeling like designing another one. So yeah, I'm gonna just export. Yeah, that would be what I would do as well, something like that. Okay, so let's export NEMA 23. Let me see what is included. Oh, okay, it's just one body. That's nice. Okay, so I can export it to the functional assembly, and of course I'm gonna need to change it because I'm gonna rename it. But I don't know what to rename it. Okay, let's go 76. So I really would like to use other motors on this machine. So, and later for the enclosure, it's important that we make the motor the right size. So for now, what I'm gonna do, I'm just gonna put a plane in here. I'm gonna split bodies. I'm gonna split this body according with this plane. And now we have two pieces. Now we should have two bodies, and I can just grow this motor to the size we want. So let's take a look at what size we want, because I'm not sure where is here. Okay, we're gonna talk about that in a minute. So I'm not sure about which motor I'm gonna use yet. So let's go for a bigger size, just in case. Hybrid step. NEMA 23. So I'm aiming for something like either a 2 Newton meter or a 2.5 Newton meter. Come on, go away. So this one, it's a 2.6, which looks good actually. So let's see if they have the dimensions in here somewhere. I'm just interested in the length because okay, here we are. So we have 83, so 103 from the base. So 105. Let's put 105 just to be sure. and I'm gonna give it a little extra, of course. Oops, sorry. Fusion. Okay, so in here we have. Okay, so let's grow it 5 centimeters, basically. So what we do is we move the backside 5 centimeters, and we just extrude this guy to this guy, and voila, we have now we can rename it to 105 millimeters. And now we can import it to our y-axis. The shaft, they say it's about 26 millimeters actually. I haven't checked the size of this shaft. Okay, so this one, it's smaller, but I can always cut the original one, and actually I want this thing to be the smallest possible. So if I need to cut the motor axis, it's not a problem at all. So for now, let's keep it like this. Even this size is probably too long. So join. And this is exactly why I would like to, yeah, probably I'm gonna even cut it more. This is exactly why I was looking for a smaller Hey, another CG. How are you? Okay, guess we are a little. Let's go midnight. Repeat. And mix it. Fine. For now it's all good, doesn't really matter the direction. Okay, so yeah, this is it. Okay, good news is, yeah, kinda. Kinda. Okay, let's check on the capture position. Where will the motor holes go into this piece, so we can decide what to do. So I'm gonna project that guy. It's not perfect, but okay. Fine. Why did okay, because I'm stupid. Okay, I'm gonna do it again. No, this is a much longer stepper. I'm doing the design with a longer stepper because so this is about twice the size of the original stepper. Since I really intend to use hybrid steppers, so closed loop steppers, I'm gonna make the drawing. I'm gonna make the drawing with the size I need just because of the enclosure. So the ones I want to use are these guys or something like these guys. Probably they're not gonna be as big, but it's gonna be something like this. So they are bigger because they have the encoder on the back. So here is the encoder for the closed loop, and the stepper is actually from here to here. And these are, I'm not sure why this is in Portuguese, but so most likely I'm gonna use these ones. So they should be a little smaller, not much. 2.2. Definitely I'm not gonna use the 3 ones, so that are even bigger. So yeah, probably this is gonna be my choice. Anyway, let's go back to Fusion. Well, tomorrow I have some NEMA 34s in my shop, which I bought years ago for a project, and it's a shame they were never used, and they have huge drivers. They have proper drivers, and I should sell them. They are brand new, and I bought them at least 5 years ago, and those things are huge. Tomorrow, if I remember, I'm gonna grab some, and well, tomorrow I may not stream. I don't know yet. We'll see. Okay, so as you guys see, we have a problem in here. Okay, let me check what's the distance between holes. We can do this on, oh, it's 47 millimeters. So let's do it in here. So in here we can, but in here I can see, let's see if I can close up the, I can. How much? I want some space. Let me finish this sketch. Actually, let me delete this sketch. Yeah, I have some NEMA 34s, closed loop, big ass steppers. So we have 1.5 millimeters. That's way too much. We don't need that much. But something even better, it's changing these radius on the fillets for more, which will give me more meat. Okay, let's do it 10 maybe. Okay, that might be too much. No way, I can. You have no idea how big they are. You have no idea. They are fucking huge. And actually I have 3 of them, and one, yes, because that was supposed to be for a milling machine, a big milling machine. And the Z one I have, I believe, I'm not sure, but I believe the smaller ones or the less big ones are 8.5 Newton meter torque, and the Z1 it's 12.5. So it's freaking, it's something, it's this big. It's been a long time since I saw them, and shit, it's a shame I never used them. And they cost me a small fortune back then. But that project was... Oh, okay, that works. Okay, this works. Because I bought at back then I bought a manual milling machine, and the intention was to convert that milling machine to CNC. But then I got so used to have a manual machine, because it's insane the work you can do manually. Just touch up stuff, some quick stuff. You don't need to program anything. You don't need to do shit. Just move some levers around. And I decided, okay, no, I'm not gonna convert this machine. I'm gonna keep it manual. At worst case scenario, I'm gonna buy another one and convert that one. But then I decided to make my big VMC, and by then I decided to use servos, and those guys fell in the limbo, and they are there in the box, all dusty, completely new. Big ass drivers. I mean, the drivers for those things are, it's a box like this big, like this like this high. Tomorrow, if I remember, I'm gonna grab a set and just to show up, just to compare an NEMA 14 or an NEMA 17 with a big ass NEMA 34, with a NEMA 23 in the middle. It's insane. It's stupid big. Okay, so let me do the... Yes, manual stuff. Everyone should have, like, who has a shop, a manual mill and a manual lathe. It's a must for just the small stuff, not for production or anything like that, but for small stuff. It's insane the stuff you can do with that stuff. Okay, so we need a rectangle, center rectangle, centered on this circle. Let's do 47 by 47. Yeah. X4. No. So these are supposed to be M5 screws. And yeah, we have problems. Okay, so I'm just gonna do this, but we need to figure something out on this thingy. 4.2. Yeah, yeah. Macros from, and how is it called? The Linux CNC from Tormac. Pet Pilot, I believe. I believe so. It has some very nice stuff as well, especially for lathes. Okay, so my intention would be to make this a single piece, but I'm seeing that's not gonna happen. It's okay here, but it's not okay here because we have the screw heads. Well, actually, M5s, I believe it's 8.5 millimeters, the head size. So yeah, okay, that's not gonna happen. We could use M4 screws, but not gonna happen. So here's what we're gonna do. So we don't need this big block anymore. There's no need. And so this would be kind of fine, I believe, if I do, let me put a 5 millimeter circle, 5, not 3, 5 millimeter. Nah, yeah, it should be on the edge of good, but there's another stuff that I'm not considering. Where did the thingy went? Probably I press V. So we have the screw heads in here. That's no point. So I made these 42 millimeters. There's no point either. So let's abandon this strategy and let's make this thing thinner, like 20 millimeters. So let's drop 22 millimeters. No, 22 it's too little. Let's drop 17 millimeters. Yeah, 70 millimeters should be fine. We have a 25 block. 25 to machine. Nah. Let me see how we're gonna make it beefy, but not as beefy. Let's see how it gets here. Okay, that's, we can do a little more. Let's do 2 millimeters more, or 2 millimeters. 27, so a 30 millimeter block. Yeah, that looks good. 27 should be fine. Okay, so here plus 2. Yeah, that should be fine. And what we're gonna do is we're gonna make 2 extra pieces, or 1 extra piece. No, 2 extra pieces. Yeah, okay. Okay, so this is gonna be the main body. And we're gonna create 2 extra pieces. First, let me design again the square where the hole's gonna be. So it's gonna be 47 by 47. Let me make all this shit construction, because this is just for construction. 4.2, right? Yeah, 4.2. Actually, I'm gonna put 5. Which one is it? D51. So D51 and D51. It's a shame, but there's no way, because these ones, the top ones, I could move them, but not the bottom ones, because the bottom ones are the ones that gonna go into the frame existing holes. So there's no way I can move this, and I can't move this more up because we are on the edge here and we are already cutting the yeah, there's no point. Well, not even thinking about. Okay, so let me make this like that. Finish. Now, one thing I need to know, it's how long. Oh shit, where is the? It's here. Okay, so from here. Okay, let me save the so I can update the model. Okay, now I can update it and okay. So we need something from here. Jesus, this is big. So 52 millimeters. Damn, that's long. That's long. Okay, before I forget, let me check something. How deep are these thingies? From here to there, the grooves. 6 millimeters. Okay, so 6 millimeters. So 27. So this is 27, right? Plus 6, that's 32, that sucks. So we need to drop. Yeah, so we need to drop this thingy. 25, 5. Okay, we need to drop these holes before I forget. Just to use, so we don't need to shave. So we don't need to shave screws. Let's drop these guys. What the hell? Why is not grabbing the center? Okay, now it is. 9. Why is it not getting the centers? Did I disable the snap? Oh, I disabled the snap by mistake. Okay. No, but it's not that snap that I want. Weird. Yeah, I need to make a part, but I'm gonna make it screwing here on the on this part, on this part of the block. I'm gonna make basically 2 bars just protruding, and so we can clamp the motor. But I'm not understanding why is the I am on the right plane. If I do project, let me see. If I do project, probably it's a stupid. Probably if I restart Fusion, it's gonna be fine. Okay. Finish, and let's probably it's because of the other. Okay, if I do 2 millimeters, I have 25. Let me disable this sketch. So I have 25 to here, then I have 6 more. So we can use 30 millimeters screws with no issue. Here it doesn't matter because it's a threaded profile. We can go as long as we can. We can do 45. We should be fine. Okay, so the idea here let me check, okay, let me save and check to be completely sure we are okay. I'm gonna need to make it a little bigger, so this thing steps a little under just to make sure it's not. No, it should be fine. Should be fine. Let's do it like that. So what I'm gonna do is I'm gonna do, okay, let's get back to, okay, I'm gonna delete that sketch, pissing me off. Okay, now he's complaining about what? So I'm gonna do 2 screws in here. Can be, I'm gonna do M4s. 3.6, 3.3. I don't forget 3.3. Actually we can do, we can do both on top and bottom. So let's orient them. So align this one with this one, this one with this one, this one with that one, and this one with this one. Okay, so we can make them 15 millimeters apart. Should be maybe 20 millimeters. Let's try 20 first. So we're gonna make them 10 millimeters from here. Not 10, 5, sorry. From here. Same story from here. And let me create a midpoint in here. And I'm gonna create a line between these two guys. It's easier. And create a point and midpoint and align these two. Okay, like that. Yeah, this should be fine. Maybe Yeah, it should be fine. Yeah, fine. This is fine. Let's finish sketch. I'm gonna do some threads in here. Minus 10 millimeters should be fine. Now I'm gonna do a rectangle around them. Let's say 32 millimeters should be plenty. I'm gonna align these and align these, and same story. Point, meet. Okay, I need to move this thing into place first. Actually, I'm gonna coincide them, but for now, because I need this thing to be 10 millimeters for now. So yeah, let's do coincident. No, actually, let's not. Actually, let's create another point. And like that, exactly like that. And let's do the same story on this one. And define the same like that. Okay, so now we're gonna make two new bodies. So we need to do 52 millimeters, roughly. 53. Well, probably it's gonna be less. Let me do, yeah, because I want these parts to be the small as possible. So what I'm gonna do, I'm gonna shorten the shaft here 5 millimeters on the motor. I'm gonna delete this chamfer and -5, because I want the motor close as possible from this piece. Ideally, I would use the shorter block, but okay, I need to edit the joint because I deleted the alignment. Flip, yeah, like that. Yeah, that's nice. So now we are 47. Let's do 47.5. So 47, let's do 35. And let's make new bodies. And I should have done just one and then copy. Yeah, it's easier. Okay, I'm gonna do that. I'm gonna eliminate that one. I'm gonna leave the sketch, doesn't really matter. And I'm gonna keep working on this one. Okay, so here we're gonna do a 7.5, 8 should be fine. Counter bore. We're gonna go like down 25 millimeters, 20 millimeters. Yeah, 20 millimeters. So we can screw in. Okay, I need to change. Here it's 4.2. I need to project this one. 4.2. And go down there. Here. Go. Like that. So we can use two M4 screws to attach this piece to there. And here, and here, now we can use the project this piece in here, and let's create the pattern for the motor holes. X theme. So here 4.2, because they're gonna be threaded as at 5. 4.2. And here we can do some funny stuff, like what? Okay, let's do it like this. 10. 10. Now let's create a line, tangent here, and a line, tangent there. Same story. Together with this one, 12. Some fillets. This is a big ass part. Okay, the year doesn't really matter. Let's put 7. Yeah, don't like it. Fine. Okay, let's add a little more. Okay, let's add a little more on here. Instead of 32, let's try 36. Finish sketch. Let's see how it goes. Shit, I really don't like this one. Okay, let's stop there. Let me delete this one. Oh, yeah, that makes it worse. Kind of makes sense. So instead of bigger, I should make it smaller. So 30. Let's see how it goes. Oh yeah. Yeah, this should work. And 7 here. It's gonna always go downstairs. Okay. Yeah, that's fine. Leave it. Leave it. Leave it. We can always do this now. No, I'm making on the bottom. Give me a second. Yeah, that's fuck off. Okay, so I'm making threads here because the motor will attach here, and I'm making threads down there so I can use screws to attach this part to that part. Let me see how long these screws are. 25, that's good. And this is not good. 32 millimeters is a long way to go downstairs. We'll manage somehow. And okay, let's put here motor mount 1, motor mount. Control C, Control V. Oops, this is not what I want. This is what I want. I want to turn it. No, no, no. J. Oh, okay. So let's align. And if my math is right, I might do this block longer so these parts go smaller. We'll see. That's something easy to do. Oh, if everything is right, the motor should be pretty much, yeah, it's a little short, but that's not a problem. And everything should fit just fine. Yeah, but if I make this block longer, I'll need to put a slot so we be able to tighten this screw. So yeah, I think we are fine like that. Yeah, I think we are fine like that, so we can do just some fillets in here. Then it gets a chamfer, but I don't like to design chamfers because it makes the parts a piece too harder, but basically harder to design to program, to CNC program them. So I'm gonna leave them there. Everything else should be fine. And yeah, this should work. Yeah, to make the toolpaths, it's kind of it's doable, but I prefer just to leave the, unless it's a functional chamfer, I usually don't design them because it's easier to make the path for the machine with the hard edges. Okay, so let's call it done. And what? Why did my YouTube already stopped again? Okay, so we can update. Let's do the front part. The front piece should be easier. It should be just a square with the hole for this thingy. Let me check one thing. Yeah, this doesn't come nearly there. Let me check the... Okay, I'm gonna close that one. Oh, okay, so this one, but we can always do a printed part on top to hold the home switch. I'm not gonna use... Actually, I haven't seen... Let me check what kind of home switches the Milo kit comes in with. Where is it? Electronics, maybe? So that's starter. What's that? Milo Long John? No. What's this? Milo Electronics. I have no idea what... where is the... Nope, front. Let me check something here. Don MC, welcome to our Discord. Okay, so we have the power and inlet thingy. We have the holy shit button. We have an 8 gig memory card. Okay, it's not here. You have some kind of expansion board. 2 relays. I have no idea what's that. MB, Pro, whatever, doesn't matter. Okay, so it's not in here. Shit. Everything was inside this box right now, but doesn't look like it's gonna be... Again. Okay, so it's not on the electronics box, maybe it's on the cable harness. So starter kit, no, definitely it's not on the starter kit. Let's see if it's on the... Oh yes, it is. Okay, so yeah, it's gonna use... Nah. Nope, negatory. I'm not gonna use this. So we're gonna need to figure out something else. It's still at the factory. No. I was kind of hoping it would use optic switches. So basically it's like a regular switch, but it's actually internally, instead of a spring with a contact, it would use optic. An optic switch. So no, I'm gonna use my own. I think I have, pretty sure I do have optic sensors somewhere in here. Even if I don't, I'll order them, because I definitely want something more precise than lever switches on my homing system of this thingy. Okay. Go back to Fusion. So yeah, let's go back. Okay, so I don't see the point of making all of these in aluminum, because it's going to be a big block and lots of it's going to be waste. So yeah, let's see what we have here. 9.8 millimeters, which is good. We can use 12 millimeter, or we can do two pieces, one, but yeah, I don't see the point. We can use a printed part. We'll see. It's not absolute, because if we do a big aluminum part, it's going to be huge. It's going to be like a block of 50 millimeters by 80 millimeters, where a bunch, like pretty much in the middle here, it's gonna go to the garbage. But let's see. Let's see what we come by with. Okay, so right now I'm gonna start with 80 by need to look into my other one. HTPCCF? Jesus. What's HT? High temperature? Okay, let's start something like 60. Yeah, okay. 80 by 62. Oh, that's cool. Does it print well? So 80 in X, 62 in Y. And let's start with the 9.8 that the original one has. We might need, pretty sure we're gonna need to beef this one up. We'll see. Or maybe not. No, probably we won't. We'll see. Okay, let's start with this. Let's start, actually, I'm gonna do it in here. We're gonna do a bunch of holes. Well, here, yeah, here we don't need a lot of holes. Here we can do 4 holes. It's fine. So 5.2, 5.2, 5.2, 5.2. This one, horizontal with that one, vertical with this one, horizontal with that one, and vertical with that one. 10, same and same. 20. Fine. Jesus. Hey Spectra. I use Fusion. Fusion Cam, I really like it. What's going on with this guy? So what do we need more? Okay, now we need somewhere. Should be the same. Shit. Where is my... Okay, I closed it. I need to open it again. How can I disable this goddamn... Oh. Okay, give me a second. Brave. So it's coming from my other computer, right? Yeah. I can just close Discord on that PC. That makes it easier. Okay, so let me open the Y mount again. And let me go where I designed this circle, because this is, nope, actually it's that square. Okay, so it's 36 from the bottom. Right. Okay, I'm gonna do the same. Okay, we may need to do this plate a little thicker. We'll see. What do I want? A center rectangle. 45, 45. And 36. Yeah, it's fine. Now create point. Okay, for now I'm gonna put just a 2mm all on it. Now if I remember correctly, shit, I don't. So this is 30, is it the same? Let me check. FF10 dimensions. Okay, FF10, we have, shit, this is too small. Okay, now it's better. Oh, this is much smaller, which is nice. So DG6, it's 28. So 28. create point. Where is the shit? Midpoint. Create point there. And now it's my phone. There. Boom. Okay, we can create the whole pattern as well on the same sketch. So the old pattern is what? PCD, okay, it's 35. X, and the holes are D1. For D1, countersunk D2, Z, okay, so 3.4. So these are M3, so 2.5. So these are M3 threads. I have some PC CF in here, but I never used it actually. Okay, so now we need a line there and an horizontal line here, so we can create a 45-degree angle. Jesus, AliExpress is on a rampage. Wonder why. Thank you, AZ. Okay, I need to get this thing done. Okay, so let me do some fillets here. So I press F for fillets, if you guys didn't notice yet. And I think I used 10 on the other guy. Let me check if I used 10. Yes, I used 10. So we should be fine with 10 here as well. Okay, let's call it the FF block. FF10 or Y FF10 block. And let's see how we are. Milo on my function. And Y FF10 block. Okay, so we need to rotate this guy. Okay, let's locate the thingy. J for join. Boom. Huh. Okay, yeah, they're fine. It looks good for now. So I guess I can Okay, we have 7 millimeters there. We can do 7 millimeters. Or maybe not 7, but 6 should be fine. Okay, let's try 6. So minus 6. So yeah, we're gonna get, well, it's not that little. So let's get this straight. Yeah, we can do more. Yeah, we should be fine. Should be fine like that. So this block in here doesn't do any strength at all. So it doesn't deal with any forces. The only purpose for, let me close this. We haven't done any changes, but okay, fine. So the only purpose of this block is actually prevent the ball screw from wobbling. And this bearing here, it's completely free floating. So there's nothing. This is just a guide, like a guide for the ball screw. So we are good. So now we can actually do some changes on the ball screw itself. Okay, so we are about 16.5 millimeter away from the wall there. I don't know where this weird number comes from. Shouldn't be at least that weird, but doesn't really matter. Oh, it's probably from the position where the bearing is in here. Yeah, it doesn't really matter, because like I said, this is free floating, so we have some space. If we do a cross examination on this, you see this thing is completely free floating. So as long as the bearing is inside the block, we're good, and we have a good amount. We have like 2.5 millimeters to each side, so it doesn't really matter. Dude, of course I'm going with rolled ball screws on this machine. I'm not gonna sell a lung to buy some grounded high precision ball screws for this machine. I have high precision grounded on my VMC, and that cost me half a heart. I'm gonna do double nuts though, which is something completely overkill on this machine. But yeah, I decided to go with that. But no, there's no way I'm gonna spend so much money on ground screws for this thingy. Okay, so let's go and shave a little bit of our ball screw. So basically I need to remove I'm gonna remove minus 16.5 millimeters from here, and the piece I remove it, I'm gonna add it in here. And now And with this, we should be able to mount the so yeah, it should be a tiny little bit of overlap here, but it doesn't really matter. And now we have a piece in here where people can mount the manual handle if they want. I'm not sure how much the Milo actually have in here, but yeah. So if I shit, it's not this one. So this is 8mm, or actually this is not. Why this is 9? Why the hell is? Oh, probably it's to get some kind of bushing in here, because the ball screw, it's 8mm. The lead screw, sorry. This is weird. So the lead screw is 8mm. Makes no sense that this hole is 9mm. So probably it's to get some kind of bushing. So the threads, I don't know. I'm not gonna use these anyway. So, but yes, it's possible for whoever wants to put a handle in here. You can install a manual handle. And okay, I don't need these to be so big. Okay, let's do that change. This thing is way smaller than the other side. Okay, we can shave it like 8mm or something like that. Okay, not this one, this one. So let's do it like 37. And that way I can also make this one smaller, like 58. Let's see how it is now. Oops. Okay, that's a little too tight. Well, it's not too tight. I just need to open the fillets a little bit. I'm already spending way too much money on this machine, but because I'm liking it. I haven't started building it, and I'm liking it already. Besides all the shit I found out in the design. Yeah, a little more. 7. Okay, 7. I like that. Even if you go with a C5, a precision ground C5, which is the cheapest one, it's not cheap at all. And if you go to C3, that's what I have on my machine, which are, it's not ideal for a VMC, but it's good enough for my needs. It almost doubles from the C5 to C3. When you go to C1 or C0, shit. I didn't even ask. Okay, I'm gonna do a big ass chamfer in here, like 10mm, to see how it lands on the design. Probably I can do more. Yeah, I can do more. I already seen I can do more. Yeah, I can do way more. So I can do 14, right? I think. Or no, I can do actually 18 to land in the same. So let's do 17. Really? C7? Okay. And it was ground C7? I never seen ground C7. The lowest grade I seen on grounded ball screws was C5. Yeah, that's what I like. And we have no problems. Okay, let me activate the whole thingy and disable the... Yeah, okay. Okay, this looks good. So I only need to design something to hold the... to mess with the... Oh, you know what? I think I'm gonna make this piece bigger. Ah, okay. C3, yes, C3. It's what I have on my machine. It cost me a freaking kidney. Or no, it was more. A kidney and I don't know, half of the intestine. It was very, very expensive. Paid off though. Okay, so I intend to do covers on this thingy. Yeah, maybe then we'll adapt something with a 3D printer. We'll see. I need to study. I haven't studied that yet, but I want to do covers. I don't see here it's gonna be tough because this thingy probably I'm gonna lose travel. We'll see. I need to check with the whole machine mounted. Let me activate the... Where is the table? Okay, so there's no way to get more travel. Well, we can get a little more. Let me align. Okay, let me lower the spindle. Can I dejoint? There's no motion, I know. I want to move it. Shit, I can't. Damn it. Yeah, I seen it. It's not cheap, but I wouldn't spend the money on it because it uses the LED screws. So for me, it's like nonsense. Okay, so we have very little space in here to mount the covers. Yeah, you had pretty much no. Well, actually, let's take a look into the. Let's see if I can find the link. There are some pieces that make sense, but most of them no. Milo, CNC should be enough. There we go. Shit. Okay, maybe I can look into here, Milo. Yeah. Okay, so they don't even make the most important parts. Are these all the parts? So that's the Z, that's the X, that's the other X. This is the spindle clamp. This is the X nuts, Z nuts, Y nuts, Z plate. No, actually this is the saddle plate. This is the Z plate, and this is the Y, and that's the other Y. So yeah, they don't even make the most important parts, that the parts that the machine would gain the most in the kit, which is insane. And yeah, and that's for the modest part of $600 plus 100. Anyway. Yep, basically. And it's via UPS, so you can put some fees on top of the. Yes, you gonna shit. Yeah, I can't because I am not logged in. So you're gonna get a discount from taxes because this price includes the taxes, but then you're gonna add them plus something from an expensive carrier. So yeah. Moving on. Okay, so we have the front plate done. So it's time to move to the x-axis. Yeah, I should have done an extra. So saddle plate, all these things should be here. Not the table though. The table should be... Okay, let me make a new component in here. I'm gonna call it x-axis. And I'm gonna put... No, not these, not these, not these, not these. The table. Yeah, only the table. I'm gonna go there. Capture position. Yep, exactly. Okay, so here we're gonna get some... We're gonna need some stuff. First thing I'm gonna do, I'm gonna actually edit the table. I'm gonna edit the design, the drawing, sorry. And I'm gonna add the holes in this thingy, because we're gonna need them all. Well, I'm gonna add just one for positional, or position. And I could have done the other one in here. Edit feature. Okay, so now we can start designing the thingy. So I'm gonna do the full, I'm gonna do a part very close to the original one. Maybe I ain't gonna do it. Why? Okay. Never mind. Maybe I'm gonna do... Let me check the original one. So the original come up here. How much? Yeah, I might do that as well. But not as much. I'm not gonna do as much. I'm gonna do like 8 millimeters on top. So this is 116, right? Yes, 116, okay. Let's start designing the sink. So it's gonna be something like 160. Come on. Then we're gonna go 28. Why didn't it? Okay, I have no idea. Then I'm gonna go and do 80 on bottom. I'm gonna create a point, well, a few points, a point here, a point here. Let me align these guys. So here should be how much? Well, I'm not sure. Let me check the original one. It should be close to the original one. Okay, a little less than the original one, I think. Yeah, it should be close because I want to, yeah, okay, let's do it close. So 91.25. That's a weird number. So I'm gonna do 90. For now. Let me do construction line in here. So this should be 40, I believe. Yeah, it should be 40. And it should be 80. So this is the size of the frame. Just for me to have an idea. So this one should be at the same level as that one. Yeah, probably I'll do that as well. This is what? 6.5. Okay, so I'm gonna do 28 plus 7. Oh, okay, this is the, okay, I was seeing wrong. So it goes there, goes there, okay. Okay, this is not 40, this is 48, I'm sorry. Yeah, now it makes sense. So I'm gonna do it in here, then I'm gonna do it in here. This is just a rough shape for now. Fuck, I forgot. I didn't want all the screws in here. So I'm gonna create a line from here to here, X. And I'm gonna create a line from here and from here. We'll get there. So here should be 18 because it's 8 from the top plus 10 from half of the frame. And we should have a bunch of 5.2 millimeters. 5.2. Actually, I'm gonna call it this guy, D8. So D8. Actually, this guy should come from here. 1, 2, 3. D8. 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 D8 and D8, and this guy is X as well. These ones are like that, and this should be 20, and this should be D8 and D8. Okay. So these should be 10, and these should be 20, and yes, I could do a pattern for these guys, but this is a mess. Let me put this guy on here. Let me put this guy here. Let me put these guys somewhere more centered. This doesn't really matter. This is the original one. Come on. Okay, should be something like this. Let's call it, I don't know, 20 millimeters for now. What's the original one? Actually, it's 20. We'll see. Probably I'll need more. We'll see about that. Most likely. We'll find out soon enough. Okay, so let's import our sink to... So we're gonna work on the x-axis now. Oh, I haven't saved it, so... Let's call it X motor mount. Gonna be actually the block mount, but doesn't really matter for now. Let's put it to work. Okay, let me close the motor, the FF block. Okay. Today I'm gonna finish the stream a little earlier, like in half an hour or something like that. Because I have some other stuff I need to do to prepare to work tomorrow. Shit, I need to... Okay, let me do something else in here. Let me do just... a 45 by 45 centered rectangle. I know I want it centered. So let's start with that. I don't know the position yet. We'll figure that out later, and I'm gonna do at least 15. Probably I can do that much, but doesn't matter for now. What am I doing tomorrow? Tomorrow I have to machine 3 parts for 3 custom parts for a gun. Actually, yeah, I have them here. I designed it today, earlier today. Where is... It's here. So it's these 3 parts. This is simple. So this one, it's kinda simple. I have this one. This one, it's a little bit more complicated, but so I have the programming here. Someone was asking what I was using to program the mill. So if you guys want to see the simulation, so this is at yellow, it's the stock, and these are the diverse operations. So basically I'm gonna start like that with a big ass mill, 12 millimeter mill. Let's speed this up. No, I never used Mastercam. I heard it's like the ultimate thing for CNC machines, but since took me so long to make the post processor for Fusion for my specific machine, then now I just don't have the nerve to do it all over again. I don't know if even they are compatible. Pretty sure they are not. So okay, so this is the first setup. Then this is a second setup. Actually, I should have. If I do this, it should be doing everything. Yeah. Okay. Then I need to rotate the piece so I can machine the lower side and then the sides. And yeah, that's the part done. This is a simple, just a covering plate, nothing even worse. And then it's this one, it's also fun. But yeah, it's what I have to do tomorrow. Let's get back to business. I'll take pictures and I'll show on Discord after they are done. If everything goes right. Okay, let me... shit, I forgot to... Okay, let me do first update. Yeah, okay, we are on the right side. So I just made this feature here to make sure I had the part assembled correctly. Okay, so this is a good start. I'm gonna make the holes in here. What do I need? Need to go here. Let's make the hole patterns in here. So I believe this is 35. If I remember correctly from the... where are BMS Beetle and Milo function Y Monto. Okay, 34 and a half. 34 and a half. So it's 34, but I do an extra half a millimeter for alignment. So we have some play for alignment. And we have another circle, 42, if I remember correctly, where we have the 3.3, I believe. I think they are M4s. Okay, let's do all the alignments. So horizontal, this one with this one, this one with this one, and this one with this one. Yeah, it over constrains. So we need a straight line in here or a horizontal line. X for construction. Another one in here. Same story. X. Then we do a D for dimension between these two, then 45 degrees, and we are set. And E for extrusion, and let's make some holes. Boom. Okay. Fine. Now, actually, I forgot to check something. Let me check. So supposedly this is a 550, so 550 millimeters, yes, ball screw, which is awesome. So I'm gonna copy this guy. To exactly where we are. And I'm gonna rename it for X. I'm not sure about the size yet, so we're gonna rename it again later. Okay, so this guy, it's 10, right? Yes. Okay, so let me do that. Here. F for fillet, 10, 10, 10. Let's see. Okay, so now what we're gonna do, we're gonna import another FK10 on our X-axis. Let's rotate it according to our needs. 270. And let's put it in place. Align. Shit. Fuck, I fucked up. Okay, let's use this guy and that guy. J for join. It's rigid, so it's gonna be fine. Like that. And from now on, we're gonna need to do some guesswork. So let's import, let me check if everything is aligned. It is. Let's import the ball screw. Let me rotate it into place. It's fine. Now let's import two nuts. So supposedly it's going to be the same orientation. We'll check in a minute. So we can always do one. And same story, we're going to make it slide. So J for joint, motion slider. We're going to get this guy and this guy. And we should be okay. We can't because if I ground this guy, then I can't. Okay, but I can. Why can't I? What about pin? Capture position. Okay, pin works. Okay, we can move this thingy as we should. Unpin. What next? Huh. Starting to see some problems already. We'll see. I might not be able to use these screws. We'll see in a minute. Every problem on its own. Okay, so let's put what? Let's put another nut. No, let's put this in place, and we'll deal with the nut later, the second nut. Okay, so let me join these guys together. No, I don't want a sliding motion. I want a rigid, like that. And okay, I need to rotate it. How much? Okay, let me inspect so I have more precision. So 138.56. That's a weird number. We want it to be so oh well, I don't need a calculator. So 138.56. Fine. So let me edit, make sure I'm selecting the, yes I am. I'm gonna edit the joint. I'm gonna rotate it 180 minus 138.56, I believe. Yay. Yeah, and we are straight now. Okay, so now we gonna do what? We're gonna disappear with the table so we can see what the hell is going on. And let's move the nut, and we are inside the plate. How much inside the plate? Let's check. Let's select the face and the, oh, I have this thing, it's unselectable. So I need to make it selectable again. Okay, so these to that. We are 5. Okay, we have at least 6 millimeters up. Okay, we have plenty. Kinda. Plenty. We'll see. In a minute. So, let me do something first. Well, not first. Let's edit this guy. Let me do... Okay, before I do that guy, move the timeline. Let me do a sketch here for 9 millimeters because the screws, the M5 screws, have a 9 millimeter head, and I really want to make these guys counterbored. So I'm gonna leave that drawing there just as a guide. So we have plenty, kinda plenty, but we have enough. shit. Actually, I want that drawing before this guy. Can I? Yes, I can. Okay, so let's edit this guy and let's move this guy up. 41, I believe. Let's try 41 to start with. Ideally, I want more, but for now, we'll see. Okay, and now I should be higher. Oh, actually I'm not. Actually, I think I'm right on. Well, fuck you. Come on. Really? Okay, so I have a slightly disalignment in the angle. Probably because of the joint with the ball screw and ball nut, but I don't care. So I'm gonna try this way. Inspect that to that, and I'm gonna put like this. So I have a Z delta of pretty much nothing. So it means that I'm pretty much touching the yeah, but this thing it's bothering me. I really don't like these small mistakes. Everything should be perfectly aligned. Okay, let me check if the okay, 0 degrees, so this one is aligned. The only one that's not aligned, it's the nut, which is off by this amount. Shit, I'm not even sure if I can. Okay, let me write that number. So 3. Not even the pen is collaborating with me. Okay, 3 to 13. I don't know how to say exponential, maybe. Okay, so let me try to edit this joint again. And I'm gonna put again minus 3.13. I don't know if I can do this, but I'm gonna find out. Let's see if this make it worse. Aha. Shit, it's the same thing. How is it the same thing? It shouldn't be. It should be either 0 or twice the value, right? You see, if I put plus, what changes? Nothing changes. So it's doing nothing? Okay, let me add deg here. Okay, it doesn't let me. Okay, fine. Oh, it had deg already. It was just not showing. Edit joint. Yep. Okay, what if I do this? 0.000, so it should be one more, right? Okay, I don't care about that anymore. I'm done with it. The joint. Inspect. Here, shit. Here and here. It's 30 millimeters, I don't care. So how much do I have from here to there? Okay, so we are dead on the plate, so we need at least 1 more millimeter, at least. Preferably 2. Well, I guess I'm going to push it as much as I can. So here to here, 4, so I'm going to push it like 3 more, 44. Because I want to do some chamfers and it should be fine, doesn't really matter, but it would be nice for it not to touch. So save and let's go for it. Okay, and now where's my face? This face to this face. Okay, now we are 3 millimeters off. We are good. And so now we have another problem. It's not a problem. Probably I'm gonna need to modify. Okay, let me disappear with the column. What time is it? Oh shit. Almost time to go. Okay, you know what? I think I'm gonna use the same. No, I can't use the same. I'm gonna use a different version. And I'm gonna modify the because this thing we have. Oh, sorry. Hey, happy MFG. I'm gonna use 1204 ball screws. So 12 millimeter diameter, 4 millimeter pitch. I would like even a lower pitch, but that's the lowest of the ball. I can find anything smaller than 4 millimeter pitch, but it's already half of the pitch of the original ones, so I'm good with it. Okay, so we have to take some. Yes, the build uses 8 millimeter lead screws with 8 millimeter pitch. So as I was saying, we have to take care, because in CAD it's one thing, but we need to take care about the assembly. We need to mount this thing. It's one thing to design it. Well, gantry for do-it-yourself, in my opinion, it's worse, but because it requires more tweaking of the alignment, in my opinion. Gantry machines, I have nothing against gantry machines, and gantry machines are awesome. I have one. But it requires way more fiddling with all the alignments. In opposite to this kind. So for do-it-yourself, I think it's worse because of that, just because of that. But yeah, they work like the others. Especially if you use a gantry, moving gantry. If it's a fixed gantry, that's another thing. But if it's a moving gantry, okay. Well, I like to pretend mines are current, so. Okay, so as I was saying, so I'm gonna modify the original plate. It's just adding 2 walls and 2 threads. It's not the end of the world, but it's easier. I don't even know how they want us to. So probably they want us to have the thingy already assembled. But it's no good. So the original mounting holes for the X ball screw are these 3, and they are absolutely of no help to me. So, oh wait, yes, exactly, I'm right. So because the ball screw has to be, the ball nut has to be attached to this thingy. So when we tight the, yes, okay, so yes, I'm right. I don't like this design. I would prefer to see the table, the saddle, I mean, the full size, and then a moving table on top of the sinking. But it is what it is. So this one is better for the ships though. Okay, so as I was saying, these holes in here don't help me at all for my mounting, especially since I don't have much space on the bottom. If I had more space, it wouldn't be a problem, but since I don't have space. But this is gonna be for tomorrow because I want to, it's time for me to end the stream. So basically what I'm gonna do, I'm just gonna add 2 screws somewhere, doesn't really matter where. Well, it matters where, but not too much. But basically I'm gonna make 2 screws, 2 holes somewhere in here on the middle where we have space. And I'll make a type of where is our yeah, something like this, but instead of the screws coming to in here, instead of having threads here, we're gonna have some here's on the side and some screws going from the top. And the same design, we're gonna use the same design. It's gonna be an easy fix. Yes, I'm gonna put 2 double nuts, as I did on the axis. You can see them there on the y-axis. So I'm gonna use double nuts, preloaded, spring loaded. So yeah, these double nuts, it's an extra. It's a last minute thing. I wasn't really even thinking about it, but then I thought, well, what the hell? These things are so cheap. And since we are making the machine the best we can, why not use double nuts? And we kinda have the space for it, so why not? We don't have huge space, but we have enough space. So I'm gonna, before I forget, I'm gonna lower this guy again. 2 millimeters. So we're gonna be at 42. So we're gonna be 1 millimeter from the floor, which is more than enough. And one thing I need to check, and I'm gonna check right now. I need to activate the table. Well, I don't need to activate the table, but it helps. I need to check if the... Yeah, as I thought. Ooh. Does it pass? Oh, wait. It doesn't pass, but if I lift it again, okay, let me check. I'm lost. What do I really want? Okay, I need to know the space from here to here. Oh, 36. Yeah, okay, that's fine. 36. That means How much is this? 34. Okay, so I should have 1 millimeter to spare. Okay, let me put it up again. 44. Okay, I forgot to save. Okay, it's updated now. Okay, let me put full color on these thingies. Okay, from here to here. Okay, I have 1 millimeter. And what? I need to check here. From here to here. Fuck. From that to there, I have 3 millimeters. Okay, that's... Oh, no, that's not what I want. What I want... Fuck. It's from there to there. 1 millimeter. Okay, we should be fine. Easier is to do a section analysis from here to... Yeah, here. Should be fine. So we have play there. We have gap there. So we are fine. Yeah, we're gonna need a bigger screw though. That's a shame. Yeah, we should be fine. We should be fine. Shit. Let me ground the table. Or pin the table. Copy position. This way, yes. Yes. We have clearance everywhere. So we should be good with this setup. We should be fine with this setup. So yeah, it should work. It should work. It should work very well. So we have space. Let me disable the... Yeah. Okay, so tomorrow, I don't know if I can stream yet. Maybe I can, maybe I can't, I don't know. I'm not sure yet. Probably I can't, but if I can't, on Saturday we should finish the x-axis and start working on the z-axis. It's gonna be easy to finish this guy. We just need to make this thingy a little prettier, but we have time for that. But everything else should be fine. Oh, whoa, 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 whoa. No, 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 no. It doesn't fit. Okay. I need to increase the... the thickness of this plate. Oh shit, that's a shame. In order to move this thing back, because it will hit the cars here. Shit. That sucks. Okay, it's an easy fix, but yeah, that sucks. I really wouldn't like to, but it is what it is. So we need to increase a lot, actually. We need to increase a lot. Bummer. Well, we don't need to increase it, actually. Edge 15, 12, yeah, okay. So I'm going to increase it 5 millimeters, so 25. No, I don't want to mess with the plate. I would have the room, but I don't want. So this plate here, it's included in the kit. No, but I can't. Even I can't because of the because the rails are on the frame. So no, there's no point. No, that's not possible. That's not possible. It would be possible to kind of make a slot there, but the idea, like I said, the idea is to make a do-it-yourself that everyone can do the same modification. So we could just make a clearance here. I think we would have maybe we don't have the space either, but nope, that's no bueno. We need to get our hands dirty. So what I'm gonna do, I'm gonna increase the thickness of this thingy to 27. And decrease this pocket 7 to 9. And we should be fine now. Here. Okay, we are actually more than... But that's okay because of this side, okay. Yeah, we are 1 millimeter too much. So I'm gonna... Should be fine, doesn't really matter, but I need to increase the depth of that, yeah, that guy, -10. Because I want to put that thing as... Yeah, this is fine, like that. And we're gonna need to get creative again with the mount for the motor, but should be fine. We might need to modify these pieces so I don't need to make 2 different sets of these. Yeah, no, I won't be able to. Yeah, I'll need to get creative in here for another piece for the motor. But that's for tomorrow or Saturday. For now, we're gonna leave it like this, and I'm gonna end the stream. Don't save. Okay. Okay, guys. Thank you for watching. I hope you guys learned something new today. Today it wasn't as informative as yesterday, because it's pretty much only CAD. We're gonna use the same system or the same mechanism as we use on the first axis. So should be a little more boring, but yeah, it is what it is. Thank you guys for watching. Again, if you guys like the content, please like and subscribe. And I see you guys either tomorrow or on Saturday. The link in the description for our Discord if you guys want to join us. And yeah, I think that's about it. Take care. Have a good night. Thank you again for making me company and for keeping up with my shit. And see you guys next time. Really appreciate your time. Thank you for stepping by and have a good night.